Hi, welcome Raj. So today we are undergoing with a live AI evaluation interview round, and we are going to have this, evaluations where we will be conducting questions across tool calling and agent memory for a GenAI architect, 15 years experience. Okay, so this is what is a set, let's say 15 years experience, GenAI Architect at, let's say, persistent systems. Okay, so I'm just taking a role at an organization also so that the question stays relevant across such organizations. Okay, now we are going to start this evaluation round. You will be presented with questions, and then we have to, you have to continue answering that. And later we will do the evaluations and we'll see what all gaps we identify in this. So I'm starting a new session for tool calling and agent memory. And we are going to get started with the questions. Okay. So this is session number 73. And let me also set up my system. Okay, so we are going to get started with the next question. So the next question is,
how would you design tool calling and agent memory for an enterprise GenAI system to ensure reliability, context retention, and controlled action execution?
you can please go on.
Yeah, sorry, Devanshu, can I start?
Yeah, please, you can go on.
Okay. Uh, Question: how would you design a tool calling and agent memory for enterprise system to ensure reliability, context retention, and controlled action? Okay. So, as an architect, if I want to design a tool calling and the agent memory for enterprise system, I would be considering a designing a scalable and modular tool calling system. So, first, whenever the user sends a query, that LLM model will do the intent and understand that what is the query. Then, based on that query, the LLM decides which tool to the API. The LLM API will decides which tool needs to call. Suppose if as a user, if I want to know my leave balance, means I want to know my leave balance, the LLM in the backend, the LLM will understand the interpreted, understand the language, and understand the intent. And if I want is the content is leave balance, then if the LLM in turn identifies, yeah, we need to call the uh, Workday or HR API. Intern it will call, and based on that employee ID, based on that it will be retrieve the leave balance of that particular employee. So if when I want to the same when I want to design a agent memory, so I will be considering the agent memory into a layered one. So short-term memory, long-term memory, semantic memory. So what the short-term memory means? Short-term memory means within a session, within a active page, we want to store and we need to provide the interactive Q&A means for that I will be using into the short-term memory. When it comes to long-term memory, so I assume if we are working on the HR portal for the past 1 month at 3 months, I will be asked the number of questions. So the system needs to keep the track, and whenever asking the same questions, instead of fetching and providing a response, so from the history from the memory in the long-term memory we might be keep from the memory we can fetch it and we can show it the answer. So in this way if we design a tool calling agent memory, I can focus, it will be improve on the reliability, cost, and it will be a proper controlled execution, the answer.
Okay. So I would like to have a follow-up question on this. So the question is, let's say, if you have to maintain relevant history, how will you use contextual embeddings?
Or if I want to maintain a history,
A relevant
okay,
history.
instead of dumping entire document, suppose if we are or getting into processing 1,000 documents instead of dumping all documents into that history. So whenever the once the retrieval happens, we might be getting a top tier results. So we in the long term memory with the long term memory we can keep the only top five results, top tier results. From there we can with the prompt templates we can design a context with the proper augmentation, Devanshu.
Okay, sure. Let's get to the next question.
In a multi-agent enterprise workflow, how would you prevent stale memory from causing incorrect tool calls while preserving useful long-term context?
In a multi-agent enterprise workflow, how would you prevent stale memory from causing incorrect tool calls while preserving useful long-term context? Okay, so I will be designing such a way proper when so properly the LLM model analyze the user query with the proper intent management. Then the LLM model, so we might have designed such a way based on the query and what is the internal API tool we need to call. Uh, so with the functions, so we will be designing such a way tightly. Suppose if I said if I want to know about that mm, vendor ID from the SAP, that LLM decides. Uh, so calling the correct tool, API tool. Suppose if I want to know a vendor query means vendor ID, the LLM in turn call the correct SAP API function. In turn, the API will connect the proper SAP system and will get that vendor query, vendor ID. So prevent. Suppose if I want to prevent the stale memory, just properly, I will be following a security. Uh, Security and as well as retrieval proper retrieval mechanism and so instead of the long term as I said that instead of storing all the documents into the long term context, I believe that after the retrieval, so whatever the record context and it will get stored into the long term context, Devanshu.
Okay. Okay.
How would you debug and mitigate hallucinated tool selection caused by conflicting short-term and long-term agent memory in a production enterprise GenAI platform?
How would you how would you mitigate hallucinated tool selection? Is this question is used only tool selection or the response from the agent, Devanshu?
Sorry, can you come again?
The question is purely based on the tool selection or the on the response from the agent.
So this would eventually you can include tool selection and with respect to outcome as well, because how would you be mitigating that hallucinated output? Also, you can address. I mean, I think you can address mitigation strategies. That would be better,
Okay,
where you can uh, touch these points like memory reconciliation, I believe. And then how would you be able to prioritize, prioritizing these agents. And similarly, you can also touch the confidence data, how you can, how we can use high confidence data. Also, you can, I think, touch conflict resolutions also. So all these things you can, address.
okay,
So mitigation strategies, prioritizing strategies, high confidence strategies, and conflict resolution strategies.
okay, okay. So in this scenario, first I will be deep dive into the. I will be collect the logs, audit trails to understand reason behind the hallucinations results. What is the reason behind incorrect tool, maybe tool selection, or incorrect results. So first there might be, suppose in case of the incorrect tool selections, first I will be checking the model. So did the model interpreted the user input correctly or not? So example, if I ask leave balance means if the interpretation of the model is correct or not. If the leave balance means what is interpretation, what is output from there we got it. Based on interpretation only, it will be that the LLM model intent will trigger the call or trigger the tool selection saying that Workday or HR whatever portal. So this is one kind of mitigation. So in case of the incorrect, the answers is not up to the expectation means then I will be understanding why I will be go through diagnosis starting from the LLM model ingestion. What is the API, the results from the API we get the accurate or the expected results with the proper we handle the proper authentication authorization. With that, we will be getting a results that are the is it handled correctly. Then the the construction of prompt. So did we ask the LLM to give did we constructed the augmentation and context properly as per the uh, standards of prompt templates, are we followed it? As well as we suppose if it is a recurring query, we might have extracted from the short-term and long-term memory agent. From there, the extraction and the retrieval is accurate or not with the what how we have stored that results in that memory. These are the key things I will be diagnosing it. Devanshu. With this, I think I could able to identify what is the issue. I can able to locate the exact precise issue and I can mitigate it.
Okay, great. Okay, let's get to the next question.
Yeah, sure.
What best practices would you use to version, audit, and govern agent memory and tool schemas across teams in a regulated enterprise GenAI platform?
What best practices would you use to version audit and govern agent memory and tool schemas across the teams in your regulated enterprise platform? Okay. So when it comes to the best practices to use the version across the project, so for across the project, I will be maintaining the one version. So let's say the project version is one means. So for all the mm, audits as well as a prompt template. So where whatever the config across the entire one GenAI platform, I maintaining a unique versions. So whenever through the CI/CD pipeline, I will be adding that version whenever the pushing the major codes. Major release will happen. I will be maintaining the same versions across the project. They also same way whenever the we are designing schemas whenever you sending an input to the tool calling center, there also I will be maintaining the version. So maybe versions it will be the tool calling and schemas and all will work based on the versions they want. So this way I think it is one of the across the project if we maintain the versions through the API tool calling wherever in as a the config through where whenever we do a deployment, are we deploying a correct versions or not through the version control GitHub with that I can this is the best practice I can do it.
Okay, sure. Let's get to the next question.
How would you evaluate and optimize latency, cost, and accuracy trade-offs in tool calling and agent memory for a large-scale enterprise GenAI deployment?
We evaluate and optimize latency, cost, and accuracy trade-offs in tool calling for a large-scale enterprise data deployment. So So if I want to, if I want to evaluate and optimize the latency, cost, and accuracy, so I will be start evaluating in the all stages of the entire life cycle of the project. They want um, so whenever user hits the query, application gateway, what is the API gateway, what is the how much time it's going to take to complete the gateway authentication authorization. So to check the what are the access they are having, whether the role based access or attribute based access. Then the LLM model to to understand the intent of the user. So there, what there I will be evaluating how much time is going to take, and whenever the tool calling, the construction of the input parameters promptly will be constructed. Are we constructed the input parameters as well as the tool calling the intended tools are receiving the expected input parameters or not, and there might be a scenario that will be the latency might be take from the whenever the tool might be sending a response back to the system. So that is that how much time is that how much time is taking, whether we need to increase, whether we need to do the automation in the tool in the intended tool. So once we receive from from the tool, whenever we are constructing the context and augmentation to the LLM, so that we have to, instead of constructing the lengthy prompt with the prompt templates, are we constructing precise and consciously or not? So this will help us to this will also track the tokens, and this, if it is a large tokens, there will be a costing also will get increased. So if we precisely when come to the accuracy, whenever sending the temperature, how instead of giving a high temperature, we need to effectively give the temperatures. So these ways, I think I can effectively optimize the latency, cost, and accuracy. Devanshu.
Okay. Can you address the concept of how do we balance accuracy by tuning, let's say, model complexity and managing memory size in order to protect or mitigate this increased response times and computational costs? Do you
Yeah,
want?
if I want to address that size of the memory, as if it is I will be splitting that memory into uh, short-term memory and long-term, and semantic. Semantic memory is for vector DB. Whenever we are doing documents and policies and all, it will be storing into vector DB. So short-term memory, I will be interactive. If it is within a chat, if interactive, if you want to give the shift response, that means with this, because the size will be also less. So within the session, we can get active. So I will be opting for the short-term memory. Some in case of any lengthy conversation, if it is the response, if you're asking whatever the policy, if what is the enrollment policy for this year, there might be 1,000 documents. Will be receiving, instead of 1,000 documents, I store into the long-term memory. So I will be what are the retrieval content we are getting, top fake, top K results, that I will be storing into a long-term memory. So in maybe next week, over time next week, I will come what is the last week conversation which happened about that policies and all. From the instead of again connecting to the more LLM, connecting to the vector DB, retrieving and fetching data LLM, yeah, it will be a cost also applies. So instead of that, I can get it from the long-term memory and will be showing response. It will be also improve the latency as well as cost also. Devanshu.
Okay. And can you touch pruning and distillation techniques in order to simplify models without these models losing their performance? Can you also touch this point?
Pruning and distillation, right?
Yeah.
No, sorry, Devanshu. I don't have idea. I will just recollect it.
Okay, no problem. Let's get to the next question.
How would you design fallback and recovery when tool calls fail or agent memory becomes inconsistent during a critical enterprise workflow?
How would you design fallback and recovery when tool call fails or agent memory becomes inconsistent during critical enterprise? So when if I as an architect, if I want to design a fallback and a recovery, so fallback there might be a couple of scenarios we can design a fallback. One kind of scenarios, so whenever the entire system, the AI system will be down. So in that case, the fallback will be until the recovery happens. So I will be making sure I will ask the team to do the manual. In that as architect level, I will be providing multiple regions deployment. So if it is one region, will get fair. Suppose one design or one server or one system will get failed means automatically it will route it to the the request will route it to the different system they want. So such a way, this is one of the scenario I can able to avoid the fallback and one more recovery. So when the agent becomes inconsistent means I will be understand what is the reason behind. I will be debug what is the reason behind the inconsistent the memory. What is the response we are getting it. So if there is any fixes required in the to the agent memory, I will accordingly I will fix it, and I will if it, within a stipulated time I will bring back that system up and running it also.
Sure. Let's get to the next question.
How would you design access control and data minimization for agent memory and tool calling to protect sensitive enterprise data without reducing task effectiveness?
Okay. Okay, when it comes to the access control, so throughout the system, I will be I will be making sure that governance and security will be taken place there also. So I think the security and governance will make sure the tool calling and agent memory will be sensitive and protected by when it comes to the security and access whenever the I will be a API gateway with the API gateway proper with the SSO, MFA with role based access or attribute based access. What is the user will having it on then on data I will be making sure that data data privacy and data masking, PLL masking. Suppose even though the proper authentication authorization is there, if that user is have the proper roles assigned to it, suppose if I asking a leave balance, I might be a particular employee. I have the enough rights to get the results from the HR portal or Workday portal. When so proper encryption in the transit at rest and data masking. Uh, so whenever sending the context to the LLM, so effectively I will apply the groundedness. So wherever I could, I will be masking the data into the context data also. I think this way I can design the access control and data minimization.
Okay. Okay. Great. Can you touch uh, what are the techniques which can help us limit the retention period? Can you tell us about that?
Yeah, the retention period that maybe if we are deploying into Azure or cloud, for there also the retention period will be different. If your organization basis, the retention period will be different. So maybe if we are suppose if we are using agent memory, long-term memory, short-term memory, there we also with that retention policy, we can keep that. The data in the memory for suppose if the retention policy is saying uh, the data retention policy if saying 60 or 90 days means accordingly I will be designing such a way to handle the memory as well as the password retention policy these kind of the data and all I will be maintaining and I will be designing. I will be taking care of that agent memory, Devanshu.
Okay, great. Okay. Let's get to the next one.
How would you architect episodic, semantic, and working memory together with tool calling policies to support explainable planning and safe autonomous execution in enterprise agents?
Semantic. Yeah, whenever this is an interesting question. So how there are we having a different of memory like short-term memory, long-term memory, like this is also episodic memory, semantic memory, as I earlier told. Uh, Instead of in that semantic memory, if we are working under documents, policies, organization data, it will get stored into the vector DB like semantic. So whenever that um, so whenever we getting a results from the uh, tool, where suppose if we are calling that LLM intern, if we are calling SAP API, whatever the data we are getting from SAP, so the data related, the tool calling data related and all will get stored in the episodic memory. They also. So the semantic memory will use it only for the rack pipeline where we can documents, policies and all we can store it. The episodic memory, the response we are getting it from the intended tool, we can store it there and we can store it. That's what I believe it, Devanshu.
Okay, sure. Okay. Okay. Let's go for our next question.
How would you test and validate tool calling agents' memory boundaries to prevent cross-session leakage, unauthorized actions, and hidden prompt injection in enterprise production?
Hmm. How would you test and validate? No, Devanshu. I have no idea. I need to look into it.
Okay, no problem. Let's get to the next one.
How would you architect human-in-the-loop approval for high-risk tool calls while keeping agent memory consistent, auditable, and resilient across interrupted enterprise workflows?
How would you actually human loop? Okay, so in this scenario, as an architect, so in some of the agents, we need to write back to the in NCA end system like ERP, CRM, SAP systems. So in that scenario, this is a high risk because uh, the LLM models will predict something, and which will not whether we have to make sure whether the generator context or retrieve context is correct or not. So we can't directly update that into the SAP ERP system without proper approval. So this is a high risk one. So let's say if you want to update the vendor amount for the one invoice, so means so it will be risky without get the proper approval. So for this in this scenario, I will be involving. I will be routing the human the loop with proper with say well, suppose we as a system we can't send all the users to get approval. There might be some intended users who might know who might have to play the human approval role. So with the through Active Directory, we'll getting a list and we will be sending that he will be routing the request to the via human the loop to the end user. The end user will review it. Hey, this is the invoice number, this is the amount, we need to update it. We consent your approval or like that, we'll be getting a feedback also. Once he is provided consent, we'll get back and we'll be providing update. So with that, the entire transaction, entire flow will be once we get the approval, it will be get logged into the logs as well as entire what is the input, output, what are the informations we are doing that will be get it audited into the separate audit log, separate audited log files, and. instead of I will be storing into memory also. Suppose in a 1 month, after 1 month also, if come back, they will be asking what is the data I have updated for this. So I will be using a long-term memory. I will be updating into the memory also. They also.
Okay, sure. We'll take one more last question.
How would you design memory compaction and retrieval rankings so agents keep critical context for tool decisions without exceeding token limits or amplifying outdated facts?
No, Devanshu, this one I don't have idea.
No, no problem. Let's get to our next one.
How would you design agent memory and validation and trust scoring so tool calling decisions remain accurate after upstream data changes in enterprise systems?
No, Devanshu, I need to discuss this and I need to
No
study
problem.
the.
Yeah, you will get the report, and in that report, you will see all the missing points and what all needs to be addressed. So you can do that from that report practice. Don't worry about it. Okay. I'm just going through with one more question.
If you have any documents, also you can help with that one, so we will do learn it.
Yeah.
How would you design transactional memory updates around multi-step tool calls to guarantee consistency, rollback, and auditability across distributed enterprise agents?
So I would be whether I'm not sure whether this one is correct or not. So I can still I can
Go on, go on.
consistency. Yeah. So when come to our transactional memory, so I say whenever the tool calls, whenever the response we are getting it from the tool, so I will be designing such a way to understand that whether it is a repetitive query or it's a long term. If it is repetitive query, I will be instead of storing into long term memory, I will be storing into the short term memory. So maybe if so based on the question and the intent. So if it is not repetitive query and yeah, I will be storing into the long-term memory for the history whenever he asks about the histories and that will be storing it. Mm, when comes about that consistency rollback and I need to check it. Also.
Okay, sure.